we'll be discussing an introduction to relations and functions. So, first thing let's do is define these. What a relation is. A relation just shows how two quantities affect each other. Just as a reminder too, in case anyone couldn't be here for any of the previous lessons, all of our lecture videos are posted on my YouTube. Has anyone tried to look at those yet or no? They work okay? Yeah, all right. So anyway, that's what a relation is. We could show a relation in a few different ways. One way to do it is in a table form, where we could have an x and a y value. If x is 0, y is 0. If x is 2, y is 4. If x is 3, y is 6. That's one way we could show a relation. Another way we could show a relation is with ordered pairs. Ordered pairs would just take an x and a y value and write them in parentheses. So 0, y. Remember, in the alphabet, x comes before y, so when we write points, that's the case also. And then we have 2, 4, and then 3, 6. We could also write a relation using an equation. The equation would be like y is equal to 2x. Just plug in values for x and get what y is. And then also we have something called a mapping diagram. Mapping diagram is 0, 2, and 3. So you have one bubble for the x values, one bubble for the y value. And then you just say that they go together by drawing a line between them. So just as a simple example here, we could write the relation in a table as a set of ordered pairs. So what if I gave you a table like this? So we have -4, 0, 3, and 5. And we just had 0, -2, 1, and 1. This is really just a simple problem. It says that when x is -4, y is 0. When x is 0, y is -2. When x is 3, y is 1. And then when x is 5, y is 1. Where it gets a little trickier is when we start talking about functions. Just so you know, sometimes when I write function, I abbreviate it fxn. You see that in the notes, it just stands for function. If you read it like that, function, it's just a shorter way to write it. But anyway, what a function is it just says for every distinct x, there is exactly one y value. The way that I remember this is just one x value has to go to one y value. That's what the rule is. If one x is going to one y, it's a function. If not, it's not a function. So let's go ahead and take a look at some examples. I'm going to ask you to determine whether the relations are functions. So a couple examples here. What if we had 0, 3, another point -1, 2, another point -1, 3. And the question is that a function? It's definitely a relation. A relation shows how two things go together. But if it's a function, that means that every x value only goes to one y value. What we could do is, let's draw a mapping diagram. And usually whenever I do this, I go from least to greatest. So I start at -1 and then 0. We don't have to write -1 twice, just -1. And then it looks like we have 2 and 3. The x value of -1, it looks like that's going to 2, and it looks like that's going to 3. So the question is, and 0 is just going to 3. Does every x value only go to one y value? No, the problem is right here. -1 is going to two y values, so this is not a function. Let's go back to the definition. The definition is every x only goes to one y value. If that's not true, then it's not a function. What about if we had 5, 4, and 6, 4, and 7, 4? Sometimes it's a little bit tricky to see until we draw the mapping diagram. Is every x value only going to one y value? Yeah. So 4, -1 is going to 2, and it's also going to 3. That's not good. That's not a function. 5 is only going to one value. 6 is only going to one value. 7 is only one value. That's why that's a function. That's the difference between those two problems. We would say that this is a function. A few more definitions. We have something called the domain. Sometimes it's referred to as the independent variable. And the domain are just possible x values from least to greatest. also have what's called the range. Range is sometimes called a dependent variable. The range, if the domain is X, range is Y. Range would just be possible Y values, least to greatest. Let me give you a few examples. What if I asked you to state the domain, range, and whether a function? I'll give you a couple examples. I'll give you a chance to figure it out on your own. We had the relation 2, 1, negative 3, 1, 2, 3. We want to find the domain, range, and see if it's a function or not. Remember, we list the domain and range from least to greatest. The domain would just be the list of X values from least to greatest. We're going to say negative 3 and 2. The range would be the Y values from least to greatest, 1 to 3. Is it a function? Why not? Yeah, 2 is going to 1 and 2 is also going to 3. Actually had something like this. We had a table, X and Y, 0, 2, 4, and 6 for the X values or the domain. Range values would be, let's see, we have 3, 6, negative 3, and 6. So remember, we want to write them from least to greatest. Negative 3, 3, and 6. Is this a function? Yeah, every X values to show up once, right? So we say yes. Let's get into some that get a little more interesting here. What if we had a graph and the graph looked like this? The highest it goes is 0, negative 3. And then it just shot down like this. So again, we'll figure out what's the domain, what's the range, and is it a function? Domain means possible x values. So when we're listing the x values, we're really looking to see what's going on the left side and then what's going on the right side of the graph. So when you're looking at this graph, it looks like it goes to the left forever, right? It keeps going down and to the left. So it's going to go to the left forever. So we'll say on the left side, it's negative infinity. And on the right side, it goes to positive infinity. What about the range? The range, remember, is the y value. And the left side would be how far down it goes. And the right side would be how far up it goes. So it goes down, yeah, it goes down for forever. The lowest it goes is technically negative infinity. And the highest up it goes is 3. But we have to put a bracket there. Remember we talked about when we were doing inequalities that we use a bracket if it's included. This would be on a graph if it's like a closed circle. You would use these if it's excluded on a graph if it's an open circle or if it's infinity. That's how we write domain and range. Is this graph a function? This graph is a function, yes. The way that we can tell if a graph is a function, graph is a function if it passes the vertical line test, VLT. What that means is if drawing a vertical line only touches in one place. For this graph, if we draw a vertical line, you see how it only touches in one place? That means that it's a function. We'll do one more graph. We'll talk about something a little bit differently. What about if we had an ellipse? The ellipse went to the right 4 units, the left 4 units, and went up 2 and down 2. Now what's the domain? What's the range? And is it a function? So let's think about the domain. We want to know how far left does it go and how far right does it go. It looks like for this graph, it goes to -4. On the right side, it goes to 4. And because those are actual like full circles, it's not an outline, we put those in brackets. For the range, we're looking how far down it goes, how far up it goes. So we go from -2 to +2. Does this pass the vertical line test? No, right? So we say not a function. This is one of my favorite parts of this section, called domain restrictions. We'll move on to something a little bit different. So when we have domain restrictions, what we want to do is solve for y, then find. There's a couple different things here. One thing with the domain restriction is that the denominator cannot equal 0. So we solve the denominator equals 0, and then we omit from the domain. And I'll show you a few examples like this. The second thing we have to watch out for is that a radicand has to be greater than or equal to 0. So the way that we do this is you set the radicands greater than or equal to 0 and solve. Make sure you copy that down, and then we'll start up. All right, so let's take a look at some examples here. The directions are going to be to determine the domain for each equation. First example is y is equal to -2x plus 3. And when we do this problem, we're looking for two different things. We're looking to see, is there a denominator? Yes or no? Do you guys see a denominator here? No. Is there a radical? No. We don't have any problem with this. There's nothing that we have to worry about we say that the domain for this problem would be from negative infinity to positive infinity. What about if we had a problem like this, where y is equal to the square root of 5x plus 6? Do you see a denominator here? No, right? Do you see a radical? Yeah. So the way that we handle radicals is we make the radicand 5x plus 6 greater than or equal to 0. Subtract the 6 on both sides. 5x is greater than or equal to negative 6. Divide by 5, you get x is greater than or equal to negative 6/5. So as far as what the domain for this is, the domain would be any number from negative 6/5 up to infinity. What about if we had y is equal to 6 over x plus 3? You guys see a denominator? Yeah, so what we say is we say x plus 3 cannot equal 0. So x cannot equal negative 3. Obviously, there's no radical. The way that we graph this, the domain would be any number in the world, any number on a number line, except it can't be negative 3. It could be any other number, but it just can't be negative 3. So the way that we would write this, we would say from negative infinity to negative 3, in union with negative 3 to positive infinity. That's saying any number except negative 3. What about something like this? So y is equal to the square root of 3 minus 2x. Same deal. We look to see if there's a denominator. If there is, we set it not equal to 0. And clearly, there's no denominator, so we don't have to worry about that. And then if we have a radical, 3 minus 2x, we say that that has to be greater than or equal to 0. You'll never have both things at the same time. You're only going to have one or the other. So the way that we would solve this is subtract the 3 on both sides. Divide by negative 2. With an inequality, if you have divide by a negative. You have to switch it, right? Just make sure you don't forget that. And this switches, we talked about that in the inequality. So on a number line, what this looks like, this is 3 halves. Any number less than or equal to 3 halves would look like this. We write that as on the left side would be negative infinity. On the right side would be 3 halves. That would be our domain. We'll more just to make sure we're okay with this, and then we'll move on to the last section. What if we had y is equal to 2 over 6 minus 2x? If there's a denominator, we say that it can't be 0. And there is a denominator. So we say that 6 minus 2x can't be 0. We subtract 6 on the other side. Divide by -2. X is equal to 3. And that's what it can't be. There's no radical, so we don't have to worry about making the radical greater than or equal to 0. The way that we write this on a number line, here's 3. You could pick any number you want, except you can't use 3. So the way that we say that is from negative infinity to 3, and union with from 3 to positive infinity. First section, somewhere to go. Finish copying that and we'll move on. All right, and then our last section today